Hi Robert.
Hi.
As we just changed over to Mastervolt, I'm interested in knowing a little bit more about what's going on here.
Okay.
Because the most annoying thing for a girl is when she wants to switch her hairdryer on and everything trips out, or worse still, you have to ask permission. Please can I put my hairdryer on? Please can I put the microwave on, dear? So I'm fed up of begging.
Okay.
Yeah. So how is this going to help me?
Well, you're going to have permanent 220-volt supply on the boat. If you're not plugged into shore power, you'd have 220-volt from your batteries via this unit to any 220-volt power supply power point on the boat. Now, anytime, as long as it doesn't exceed the output of the inverter.
So it's a complete management system.
Complete management system. Yeah. You would be able to see how much power you're drawing at the same time, and how much power you're taking out the battery, and what level of discharge the battery is in at the same time as well. With your, that's your display with your touchscreen display that you've also got on your system. And because you've got two units combined as a master and a slave, you could use a really big hairdryer because you've got a peak of 10 kilowatts you could start. So you could have a big hairdryer.
Big hair.
You could comfortably run your hairdryer at the same time, run your microwave, and your husband could be working on the laptop, programming the system virtually while you're using all the power off here. All of that's monitored by the EasyView touchscreen display control and battery management system. You've got a few variations on your system. You would have one master shunt, you'd have the two DC distributions, you'd have the two combis, one as a slave and one as a master, and basically just a control of the EasyView. The shunt, which is an electronic measuring device of power flowing in and out of the batteries. If I could show you that's the unit over there. It's got a built-in fuse and analog shunt, digitally controlled, and basically what it's doing is measuring the power going into your battery and coming out again, and in that manner knowing exactly where the level of charge of your battery is by showing you state of charge, time remaining, so you could carry on for as long as that unit says there. The fuse has come back on again, which we never fixed earlier. So time remaining, power used. So if you've been blow drying your hair for the past half an hour, it'll tell you you've used 100 amp hours out there. You've got 1,000 amp hours on your boat, so you could still carry on for another 10 hours. It gives you battery voltage, basically the full status of your battery bank. We could also go back, we could monitor your DC distributions, which you'd also have two of, which we could name. And basically you're monitoring your heavy loads going through that unit, which is all fused, and you'd name each fuse. So it's in alarm, that's why it's showing it there. There, if you had an alarm, a blown fuse, by scrolling through the menu, you'd see the combi, no alarm, forward winch, alarm. So we know the fuse is blown, we haven't repaired it from earlier, so what we'd have to go and do is walk over to the digital distribution where the fuses are in, open it up and replace the fuse, and immediately the alarm goes away. And so you would do with every fuse on the system connected to it with the two distributions. If we went out there, we could monitor your two combis, which is the inverter chargers, and there you'd have state of the condition that they're in at that moment, at rest, at charging, inverting, or what they call transferring, is when you're getting external shore power 220-volt put in, and it basically transfers through to your 220-volt outputs, which then wouldn't take power off your batteries, but would enable this unit to charge while it's transferring the power. Just the mode that it's in. We could also here set what size shore power circuit breaker you have. These units have got the capability to assist either a generator or shore power as well. So if you had an air conditioner, or let's say you had a really big hairdryer that you wanted to run off your generator, but your generator was too small and you needed some extra power, what you would do is you would tell this unit to assist the generator when you start your hairdryer. And for that, it's really just the startup peak which your hairdryer would draw. In any case, so it gives you that short power, start your hairdryer and the generator would keep on going. And that you would set with that. So it'll know how much power to give. So you could do that off the generator supply or off a shore power supply. At the moment, we're on shore power, so it'll know that's what it's got to assist. And basically just gives you the condition that the combi is in. We're at the moment at 50% load, so we are drawing off this unit at the moment exactly half of its capacity. So here we've got the touch screen. If we wanted to monitor the batteries while you're blow drying your hair, we would activate the electronic shunt. We'd see that at the moment the batteries are at 100% of state of charge. With the hairdryer running, we'd be able to see what time you've got left while you're blow drying your hair, which could be a long time if you've got the right amount of batteries in. We'd also be able to see the power you've taken out the batteries and the voltage of the battery at the time, which will obviously be slightly lower while you're drawing a load off it, and the current while you're drawing. So we'd be able to see with your 1000 watt hairdryer that you'll be drawing probably about 100 or so amps out of the batteries. And just further information on the batteries, some temperatures, the time it's been running, the date, etc. That's on the electronic shunt. Also does a very nice history of the batteries. You can go see exactly, we've been running for so many days, lowest discharge, have you abused the batteries, and that'll give you a gauge of how long your batteries could still last for another 10 years or so, etc. We've also got the, we'll just go out the shunt. We've also got the DC distribution, which you'll have two of, which you could name. Port distribution, starboard distribution, and there, for example, you've got some fuses on there. At the moment, there's no alarms. Everything running off that DC distribution is working perfectly. Configuration and go to alarms. At the moment, there's no alarm, no combi alarm. So your inverter charger is working perfectly, no problems there. We got forward winch, which is the other fuse in there, also working perfectly, no alarm. We have the switch panel working perfectly. There you'd name each fuse. So you'd have inverter, winch, whatever heavy load you have running off there, for example. So you'd name each one so that when the fuse blows, you know exactly, it tells you which ones blows. Yeah, we've got a bit of a demo there, I'll show you. Also, we've got a battery charger. Whatever you have on yours, you'll have two, so there could be 8 items that you'd have listed there running that system. Then we go out of there. We also have the mass combi. And just at a glance, actually, you could see immediately at the time we're charging. While you're hair drying, for example, while you're sailing, you wouldn't be charging unless you have the generator running. So you'd have there at rest, and you could then push the combi, and it'll say at rest, what mode it's in, and from there you could monitor the battery charger, what it's doing, what type of shore power input got. At the moment we're at 50% load, what state it's in, battery voltage again. It repeats itself and it monitors the system constantly from various points. Let's get out there. And then also we can see what's happening in the easy view. That's really programming what type of language you want to run at, backlighting, and that's setting up this little system over here, which is the system basically. And then if I could elaborate a bit on the easy view and how the system works, we could look at the electronic shunt and the DC distribution on that side. We've got the electronic shunt, which has got a heavy duty fuse in there to protect the battery system, and we've got a basic shunt which is electronically monitored and controlled. So the question we often get is, what happens if the electronics packs up or stops working on here? Well, what it does is it reverts to its natural state. You'd still have the shunt and you'd still have your fuse, so your system will still be protected, and still you wouldn't be able to communicate with the controlling system, but it'll all still be working. And then we've got the DC distribution where we were monitoring your fuses on. We had the combi, we had the winch, etc., 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 all the heavy loads on there. So there you've got your fuses and DC monitoring from there as well. And then we could simulate a blown fuse. For example, if we had the port forward winch fuse blow, and if we could just go back to the easy view I'd show you, it immediately shows you an alarm. It says there distribution unit, forward winch, so you know which fuse it is. You've got two choices. You don't have a fuse immediately, or you can't get to it, but you know there's a problem, so you switch the winch off. You tell it to snooze. It'll go off for a while, and it'll come back on again. But you can still see at a glance there's an alarm. So what you do is you go and replace the fuse, and the alarm state will go away. Yeah.
That's really simple.
It is quite simple and easy to use as well. Yeah.
Thank you.
Okay, it's a pleasure.